Hello, in this first section of the class we're going to be reviewing a little bit of high school algebra, and specifically we're going to be reviewing the idea of simplifying algebraic expressions. So let's start off with the definition of an algebraic expression. It is a mathematical phrase containing numbers, operators, and at least one variable, but no equal sign. So an operator is a generic term for something like addition, subtraction, division, multiplication, square roots, trig functions, those types of things. And you can't have an equal sign. If you have an equal sign, then you have an equation, not just an expression. So here's a couple of examples of mathematical expressions. The one there on the left, 3x squared plus 4xy. Again, you see numbers, variables, operator addition, no equal sign, it's an expression. The expression there on the right, you see square roots, addition, subtraction, division, but again, no equal sign, so that's an expression. Now in this first expression, the 3x squared and the 4xy are what we call terms. The numbers in the front of those terms, 3 and 4, are called coefficients. Now something like 3x plus 1 equals 6, that's an equation. A couple more definitions here. Like terms are terms that contain the same powers of the same variables, but the coefficients may be different. So for example, here's a couple of different sets of like terms. 3x, 5x, negative 2x. They all involve x to the first power. Their coefficients are different, so they're like terms. Likewise, 4x squared y, 3x squared y, negative 7y x squared, those are all like terms. They all contain the same variables raised to the same powers. Now the last term, it's yx squared rather than x squared y, but the order is irrelevant. Last set there is an example of unlike terms, 6x squared, xy squared, and 3xy. Those have the same variables x and y, but the powers are not the same, so those are not like terms. Now, what we like to do in mathematics is write things as simple as possible, and this leads to our idea of a simplified algebraic expression. So this is an expression equivalent to an original expression, but written in the most compact form using as few symbols as possible. And so starting now we're going to talk about how can we simplify some algebraic expressions. Let's start off with a real simple example. 3x squared plus 5x squared. That's an expression. Notice that we have two like terms, so let's combine those like terms by simply adding the coefficients. 3 plus 5 times x squared is 8x squared. So there we have our simplified algebraic expression. Another one that's not quite so simple is this big long expression. Notice that we've got several like terms here, so let's begin by kind of rearranging things so we have like terms together. So x squared plus 3x squared, and then maybe we'll do the 2x plus 4x, and then plus the constants 2 plus 7. Now rearranging terms like this is completely justified by the commutative property. And now we can combine like terms. X squared plus 3x squared is 4x squared. 2x plus 4x is 6x. And then 2 plus 7 is 9. And there we go. We have an equivalent simplified algebraic expression. Now here's another one that at first glance doesn't look like there's much that we can combine, but we can first distribute. What we mean by distribute is let's take the 2 times the x and the 2 times the negative 4. So what we have here is 3x plus 2x. 2 times a negative 4 is a negative 8. And so we have, now we can combine like terms to get 5x minus 8. So there we go. We went from using 1, 2, 3, 4, 5 symbols up down to 2, and so we've simplified things quite a bit. Our last example here is another one we're going to distribute. At first glance it may not look like a distributive property problem, but the negative we can treat as like a negative 1, and so we're going to distribute that times the 2 and times the negative x to get 3x minus 2 plus x. And it's got to be plus x. Don't forget to distribute that negative to both terms. And now we can combine like terms to get 4x minus 2. So there's our simplified expression.